So we're in Chapter 1 still, Equations and Inequalities, and now we're going to talk about Section 1.4, which is three separate things: radical equations, equations quadratic in form, and factorable equations. So the first objective is going to be to solve radical equations. And as usual, we'll define that before we talk about how you solve them. Then we're going to solve equations quadratic in form. And the third objective is going to be to solve equations by factoring. And as in each section, there's a preparing for the section guide that says before you get started, it would be good to review square roots, factoring polynomials, and nth roots, as well as rational exponents. So let's get started with objective 1, solve radical equations. So if the variable in the equation is in a radical, the equation is called a radical equation. So if you have the square root of x plus 3 minus 4 equals 0, that is a radical equation. But if you have square root of 3x minus 4 equals 0, this is not a radical equation because the x is not inside of a square root. So when you're solving radical equations, it is possible to generate what are called extraneous solutions when you square both sides of an equation. So you must check your possible solutions in the original equation, not in any of your steps along the way, because it's possible to generate these extraneous solutions that don't work in the original equation. So we'll talk more about that when we look at some examples. So we're going to look at examples like this in class, and I want to do these together so we can talk about them as we're going through them. So let's look at objective 2, which is solve equations quadratic in form. And these take a while to recognize, but they're very important because they actually come up quite often. If you can transform your equation into one that looks like AU squared plus BU plus C equals 0 by some sort of a clever substitution, then the original equation is called an equation of the quadratic type, or an equation that's quadratic in form. So that U can be any sort of algebraic expression. So let's look at some possibilities where we have a substitution we can do, which then will create a pattern that gives us quadratic in form. So I want to do these examples together in class also. So notice the pattern though, that the first exponent is twice as big as the second exponent, and then the third term has no exponent. So see how number 62 follows this pattern of the first exponent is twice as big as the second exponent, and then the third term has no exponent, no variable. So we'll solve those together in class also. And objective 3 is solve equations by factoring. And this is going to be a refresher on something we already talked about of you might be tempted to divide both sides of this first equation, number 78, by x cubed, but don't do it. Remember we talked about, well, if you have an x in a denominator, it might be a 0, and then you'd be dividing by 0. So the safe way to solve this equation would be by getting everything on one side and 0 on the other side and factoring out the greatest common factor of x cubed. But then you should keep factoring because I see a difference of squares here. If you don't remember difference of squares, that would be a good thing to review. And now we have the zero product property. We just have 3 factors in our product. 1, 2, 3 factors. So make sure you're very clear on the difference between a factor and a term. So the zero product property says either x cubed is 0, or x minus 2 equals 0, or x plus 2 equals 0. So either x equals 0, the only possible way you can take a number and cube it and get 0 is if the number is 0, or x equals 2, or x equals -2. And I'm fine if you leave your answer like this, or if you make me a list, or my math lab will require you to make a list in brackets, a solution set. Okay, then number 86, hopefully your first instinct is to get everything on one side and 0 on the other side. And then we'll have a factoring problem, and let's do that one together. And then let's definitely do number 90 together, because this is a similar idea to the ones we've been looking at class with the fraction exponents. And remember that we factor out the smallest exponent, so that's going to be the 1/2. So we'll work on that one together. And that's all there is to this section. Nice short one.